The camera opens on a cavernous robotics research lab. The walls are lined with racks of sensors, spare motors, and testing rigs. Overhead, a steel truss supports a network of safety harnesses for experimental prototypes. In the center of the floor, a pair of strange, bird-like legs stand still. No arms, no head, just the lower half of a machine. Engineers in lab coats circle it, checking data on their tablets. This is Cassie, a narrator's voice cuts in. Agility Robotics developed Cassie as a breakthrough in bipedal locomotion, a machine built not to look human, but to walk like one. Cassie is about the height of a small child at full extension, but its profile is entirely unique. The legs are long and reverse-jointed, much like an ostrich, with large, rounded thigh shells housing high-torque electric actuators. Each leg is a self-contained marvel. Hip assembly, 3 degrees of freedom per hip, driven by brushless motors and harmonic drive gearboxes. Knee joints, single degree of freedom with reinforced carbon fiber linkages for strength and lightness. Ankles, 2-axis pivot with shock-absorbing feet for stability. Feet, flat, rigid soles with rubberized grip pads and embedded load sensors for terrain feedback. The central torso pod is compact, containing Cassie's lithium-ion battery, motor controllers, and onboard computing unit. Its AI runs a dynamic gait control system, software that predicts and corrects for balance in real time. An engineer steps back and gives a signal. Cassie comes alive, bending and straightening its legs before taking its first steps across the polished lab floor. It moves with a springy, organic rhythm, almost as if it's alive. The narrator explains, Cassie was designed for high efficiency in walking and running. Its control algorithms were inspired by biomechanics research, allowing it to handle irregular terrain with minimal energy use. Footage flashes on the big lab monitor. Cassie walking on grass, navigating gravel, and even moving at a running pace. In one clip, it weaves between traffic cones, adjusting its stride on the fly. A breakdown animation overlays the screen. Power, modular battery pack with 4-hour runtime. Actuation, 10 electric motors, all sealed for outdoor use. The control system, real-time motion planning with reinforcement learning algorithms. Frame, aerospace-grade aluminum with carbon fiber shells. One engineer demonstrates Cassie's agility by setting up a treadmill. The robot steps onto it and begins walking, then jogging, its stride adjusting automatically to speed changes. The crowd of visiting students applauds, the sound echoing against the high ceilings. The narrator closes with a note of pride. Cassie isn't here to carry boxes or shake hands. Cassie exists to solve one of robotics' hardest problems: balance, gait, and locomotion. What it learns will walk into the future in machines we haven't even imagined yet. The camera fades out as Cassie continues pacing steadily on the treadmill, every step perfectly timed.